Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. The AWS Certified Cloud Practitioner exam, currently referred to as CLF-C02, validates foundational, high-level understanding of AWS cloud, services, and terminology. In this video, we will be exploring 10 sample questions for this exam. The goal of this exercise is to review each question before exploring and eliminating incorrect answers, resulting in the correct answer being revealed. This is an essential technique for mastering AWS exam questions. Let's get started. A company wants to manage its AWS cloud resources through a web interface. Which AWS service will meet this requirement? Let us identify and interpret key phrases in the question that will help with answering it. The phrase to zone in on is manage its AWS cloud resources through a web interface. This is a very specific set of requirements, and understanding each term will guide us to the correct answer. The word manage implies administrative operations, provisioning, configuring, monitoring, and troubleshooting AWS services like EC2, S3, IAM, and more. The phrase AWS Cloud Resources confirms that we're dealing with the broad AWS service landscape, not just a development or scripting context. Most critically, Web Interface narrows the scope down to a graphical, browser-accessible user interface, ruling out command line tools, SDKs, or anything intended purely for developers. Option B, AWS CLI. The AWS command line interface allows users to run commands to interact with AWS services. While it provides full control over AWS resources, it's accessed via terminal or shell, not a web browser. There's no GUI, no dashboard, and no point-and-click interface involved. Incorrect. While powerful for automation, the CLI is a text-only interface and not suited for managing resources through a web interface. Option C, AWS SDK. The AWS SDKs are libraries for interacting with AWS using code. They're designed to integrate AWS operations into applications written in languages like Python, JavaScript, or Java. While highly flexible and programmable, they require custom code and do not include any interface, web or otherwise, for direct visual resource management. Incorrect, because AWS SDKs are for programmatic access through code, not a web-based GUI for managing resources. Option D, AWS Cloud9. AWS Cloud9 is a cloud-based development environment that runs inside a web browser. It's optimized for writing, running, and debugging code in a collaborative setting. While it can technically be used to call AWS APIs or write infrastructure as code, it is fundamentally a developer tool, not a resource management platform. Incorrect, because Cloud9 is a web IDE for development, not a management console for AWS resources. Option A, AWS Management Console. The AWS Management Console is the go-to web interface for AWS users and administrators. Accessible through any modern browser, it allows full management of AWS services through dashboards, visual workflows, configuration panels, and monitoring tools. It supports everything from launching EC2 instances to configuring IAM policies, all through a GUI. Correct. Because the AWS Management Console is the definitive web interface purpose-built for managing AWS resources interactively and visually. Which AWS cloud benefit is shown by an architecture's ability to withstand failures with minimal downtime? Let us identify and interpret key phrases in the question that will help with answering it. The key phrase here is an architecture's ability to withstand failures with minimal downtime. The words withstand failures signals that the architecture is expected to continue functioning even if something goes wrong. A hardware crash, instance failure, network disruption, or zone-level event. Minimal downtime means that even in the face of these issues, the system stays responsive or is quickly recoverable. These words point directly to resilience and continuous service availability, and not performance, scaling, or deployment velocity. The focus is on keeping things running even when components break. Option A, agility. Agility in the AWS cloud refers to the speed and flexibility with which organizations can develop, test, and deploy new applications. It's about iterating faster, responding to business needs quickly, and reducing time to market. However, it doesn't imply anything about a system's ability to handle failure or reduce downtime. Incorrect, because agility is about rapid innovation, not operational continuity during failure. Option B, elasticity. Elasticity is the AWS cloud's ability to automatically provision and deprovision resources to match workload demands in real time. It's a key driver for cost efficiency and performance optimization. But elasticity is focused on adjusting to load, not surviving failures. Incorrect because elasticity handles scaling with demand, not resilience in the face of failure. Option C, scalability. Scalability is about growing, either vertically, more powerful instances, or horizontally, more instances, to meet increasing workload needs. It ensures performance under higher loads, but like elasticity, it doesn't inherently address fault tolerance or uptime. Incorrect, because scalability ensures growth under demand, but doesn't guarantee uptime during failures. Option D, high availability. This is exactly what the question is describing. High availability in AWS is achieved by designing systems that operate across multiple availability zones or even regions to ensure continuous operation during component or infrastructure failures. Services like ELB, auto-scaling groups across AZs, and RDS multi-AZ are classic high availability solutions. The goal is always minimal downtime despite failures, precisely what the question is testing. Correct, because high availability is the cloud benefit that ensures systems stay operational with minimal downtime even in the face of failure. A company has multiple AWS accounts that include compute workloads that cannot be interrupted. The company wants to obtain billing discounts that are based on the company's use of AWS services. Which AWS feature or purchasing option will meet these requirements? Let us identify and interpret key phrases in the question that will help with answering it. The question revolves around three tightly packed constraints. First, the company has multiple AWS accounts, so we're dealing with a multi-account strategy. Second, they run compute workloads that cannot be interrupted, meaning reliability is non-negotiable. So any cost-saving strategy must not compromise stability. Finally, the company seeks to obtain billing discounts based on usage patterns across accounts. These three elements, multi-account setup, non-interruptible compute, and usage-based cost savings, form the backbone of our reasoning. Option A, resource tagging. Tagging is a best practice in AWS for organizing and managing resources. You can tag instances, buckets, databases, and more to categorize by department, environment, or cost center. While tagging is invaluable for cost allocation and governance, it does not provide discounts. It only enhances visibility. Incorrect, because resource tagging helps with organization and cost tracking, but it doesn't enable billing discounts. Option C, pay-as-you-go pricing. This is AWS's default pricing model. You pay only for what you use, with no long-term commitments. While this provides cost flexibility and no upfront risk, it doesn't offer the volume-based or enterprise-level discounts the question is targeting. Also, it doesn't address multi-account management or coordinated billing. Incorrect, because pay-as-you-go is flexible, but doesn't offer usage-based discounts across accounts. Option D, spot instances. Spot instances offer steep discounts, often up to 90%, by allowing AWS to reclaim the instance with very little notice. These are ideal for fault-tolerant, interruptible workloads like big data processing, rendering, or CI/CD. But the question explicitly says the workloads cannot be interrupted, ruling this option out entirely. Incorrect, because spot instances are low cost but unsuitable for workloads that require guaranteed continuity. Option B, consolidated billing. Consolidated billing, a core feature of AWS organizations, allows you to link multiple AWS accounts into a single billing group. This structure enables the company to aggregate usage across accounts, unlocking volume-based pricing discounts for services like EC2, S3, and data transfer. It's particularly powerful for businesses with decentralized operations but centralized financial oversight. Since it doesn't interfere with workload stability, it suits non-interruptible workloads perfectly. Correct, because consolidated billing allows usage across accounts to be pooled for enterprise-level pricing discounts, meeting all the requirements without disrupting workload reliability. What are the benefits of consolidated billing for AWS cloud services? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. The key expression here is benefits of consolidated billing for AWS cloud services. Consolidated billing is a feature of AWS organizations designed to streamline financial operations across multiple AWS accounts. The question is specifically looking for the benefits that this feature delivers, not just generic AWS billing capabilities. So we must focus on what consolidated billing actually does. Does it reduce cost, simplify the bill, affect budget controls, add fees? The goal is to identify which listed features are native outcomes of using consolidated billing. Option B, a minimal additional fee for use. This statement is misleading. Consolidated billing is a free feature. AWS doesn't charge anything extra to use it. It's part of AWS organizations and is designed to encourage best practices around multi-account structures without penalizing users financially. Incorrect, because there is no added fee. Consolidated billing is free to use. Option D, installment payment options. This option refers to a financing concept, which AWS does not offer as part of its billing tools. AWS operates on a post-paid model for most services based on usage. You receive a monthly bill and pay it in full. There is no installment mechanism tied to consolidated billing or otherwise. Incorrect, because AWS billing is usage-based, and installment payments are not a feature of consolidated billing. Option E, custom cost and usage budget creation. While AWS Budgets is a service that allows custom cost and usage budget creation, this capability exists independently of consolidated billing. You can create budgets whether or not your account is part of an organization. While consolidated billing can help track aggregate spend across accounts, budget creation is not a direct benefit of using it. Incorrect, because budgets are a separate feature and not exclusive to consolidated billing. Option A, volume discounts. One of the major advantages of consolidated billing is cost savings via aggregated usage. When multiple linked accounts are under a management account, AWS combines their usage for certain services like EC2, S3, and data transfer. This pooled usage qualifies the organization for tiered volume discounts. Correct, because consolidated billing combines account usage to unlock AWS volume discounts, optimizing cost efficiency. Option C, one bill for multiple accounts. This is the foundational feature of consolidated billing. Under a management account, all member accounts charges are rolled into a single bill, even though each account retains its own access, resources, and configurations. This simplifies accounting, reduces administrative overhead, and enables centralized financial tracking. Correct, because consolidated billing unifies charges from all linked accounts into one comprehensive invoice. A company is running a workload in the AWS cloud. Which AWS best practice ensures the most cost-effective architecture for the workload? Let us identify and interpret key phrases in the question that will help with answering it. The central message is, ensures the most cost-effective architecture. This phrasing immediately signals that while multiple practices might be beneficial for cloud architectures, cost-effectiveness is the overriding criterion here. So we need to evaluate each answer purely through the lens of cost efficiency, not performance, availability, or resilience. The context also mentions a workload in the AWS cloud, implying a production system already deployed. The goal is not theoretical improvement, but a practical best practice that actively lowers cost in a running environment. Option A, loose coupling. Loose coupling is a cornerstone of modern cloud-native design. It enhances modularity, scalability, and maintainability by allowing services to operate independently. This can indirectly improve long-term agility and reduce technical debt, but it doesn't directly impact operational cost in a measurable, short-term way. It's more about architectural flexibility than cost savings. Incorrect, because loose coupling improves design robustness, not direct cost efficiency. Option C, caching. Caching is another excellent cloud design principle that enhances performance and reduces latency by minimizing repetitive calls to databases or external APIs. While it can result in some cost savings by reducing the load on expensive resources, its primary value lies in speed and user experience, not necessarily cost reduction, especially if cache storage or invalidation logic isn't carefully managed. Incorrect, because caching improves performance, but cost savings are secondary and conditional. Option D, redundancy. Redundancy is crucial for high availability and fault tolerance. You replicate resources across availability zones or regions to ensure uptime during failures. However, redundancy typically increases cost by design since it duplicates infrastructure. So, while it's a best practice for reliability, It runs counter to the goal of cost effectiveness in this question. Incorrect, because redundancy enhances availability but usually increases operational costs. Option B, right sizing. Right sizing is the process of matching instance types, storage classes, and database tiers to actual workload needs. It's a continual optimization practice based on utilization metrics gathered via tools like AWS Cost Explorer, CloudWatch, or Compute Optimizer. Over-provisioning is a common source of cloud waste, and right-sizing directly targets and eliminates that waste. Correct, because right-sizing optimizes resource utilization and directly minimizes waste, making it the most cost-effective practice in AWS operations. A company has deployed applications on Amazon EC2 instances. The company needs to assess application vulnerabilities and must identify infrastructure deployments that do not meet best practices. Which AWS service can the company use to meet these requirements? Let us identify and interpret key phrases in the question that will help with answering it. The question revolves around two intertwined goals. The company needs to assess application vulnerabilities. It must also identify infrastructure deployments that do not meet best practices. These dual objectives help filter our choices. Application vulnerability assessment requires deep, automated security analysis, ideally integrated with EC2. Identifying deployments that don't align with AWS best practices suggests a need for ongoing resource evaluation, possibly tied to configuration or operational excellence. Option A, AWS Trusted Advisor. Trusted Advisor can identify certain issues like publicly exposed S3 buckets or underutilized EC2 instances and flag security group misconfigurations. However, it doesn't perform in-depth application vulnerability scans or low-level threat modeling. Incorrect, because Trusted Advisor helps improve best practices but lacks deep vulnerability assessment capabilities. Option C, AWS Config. AWS Config provides configuration compliance monitoring. It records and evaluates the configurations of AWS resources over time and supports custom rules to ensure alignment with compliance policies. However, it doesn't analyze code or scan EC2 instances for application-level vulnerabilities. It's more of a governance and auditing tool than a security scanner. Incorrect, because AWS Config tracks resource compliance but doesn't scan for vulnerabilities. Option D, Amazon Guard Duty. Guard Duty is an intelligent threat detection service that analyzes logs from VPC flow logs, DNS logs, and CloudTrail to identify malicious behavior or anomalies. It is excellent for detecting threats but does not scan EC2 instances or assess app-level vulnerabilities. It focuses on monitoring behavior, not assessing infrastructure misconfigurations or vulnerabilities. Incorrect, because Guard Duty detects threats in real time, but doesn't assess app vulnerabilities or architectural best practices. Option B, Amazon Inspector. Amazon Inspector is specifically designed to automatically assess applications running on EC2 instances and container workloads for vulnerabilities and unintended network exposure. It performs automated, continuous scanning and integrates with EC2 to discover software packages and evaluate them against known CVE lists. Inspector also checks against security best practices, such as open ports, root login enabled, and more. Since the question demands both application-level vulnerability assessment and best practices validation, Inspector is the best match. Correct, because Amazon Inspector directly scans workloads for vulnerabilities and helps align with security best practices, making it the precise solution for this use case. A user wants to allow applications running on an Amazon EC2 instance to make calls to other AWS services. The access granted must be secure. Which AWS service or feature should be used? Let us identify and interpret key phrases in the question that will help with answering it. The question revolves around applications running on an Amazon EC2 instance that need to make calls to other AWS services, and the access must be secure. We're talking about application-level access, not user logins. The access needs to be secure, meaning no hard-coded credentials. The target is other AWS services, implying use of temporary scoped permissions. So the solution must be automated, identity-based, and adhere to the principle of least privilege, with secure credential management built in. Option A, security groups. Security groups act as virtual firewalls for EC2 instances, controlling inbound and outbound traffic at the instance level. While they help secure network communication, They don't manage identity or permission to access AWS services like S3, DynamoDB, or SNS. Incorrect, because security groups control traffic flow, not permissions to AWS services. Option B, AWS Firewall Manager. AWS Firewall Manager is a security management tool for managing WAF rules, shield advanced protections, and security groups across accounts. It is designed for policy enforcement at scale, but it does not play a role in granting application permissions to access AWS services. Incorrect, because Firewall Manager helps with centralized rule enforcement, not runtime access for applications. Option D, IAM User SSH Keys. IAM user SSH keys are used for programmatic access to AWS services from command line tools like the AWS CLI, but they are associated with a specific IAM user. Embedding these keys in EC2 instance code or configurations would pose a major security risk, as they are long-lived and could be exposed. Incorrect, because IAM user SSH keys are insecure for application access and violate AWS best practices. Option C, IAM roles. IAM roles are the purpose-built solution for granting permissions to applications running on AWS services, including EC2. You attach a role to an EC2 instance, and AWS automatically provides temporary and rotating credentials to the instance via the metadata service. These credentials allow applications to access permitted AWS services like S3 or DynamoDB without hard-coding keys. IAM roles ensure secure, temporary, and scoped access, aligning perfectly with the requirements for both security and operational best practices. Correct, because IAM roles provide secure, temporary credentials to applications running on EC2, the recommended approach for cross-service access. Which of the following are advantages of moving to the AWS cloud? Choose 2. Let us identify and interpret key phrases in the question that will help with answering it. This question asks about the advantages of moving to the AWS cloud and explicitly instructs us to choose 2 correct answers. So we need to identify options that align with AWS's core value propositions. Cost optimization, like pay-as-you-go, elastic capacity management, operational burden reduction. But remember, AWS operates under a shared responsibility model, so we must not assume AWS handles everything, especially for things like security or user access control. Option A, the ability to turn over the responsibility for all security to AWS. This is a common misconception. While AWS does handle the security of the cloud, meaning infrastructure, hardware, and managed services, the security in the cloud, like data encryption, user access, and firewall settings, is the customer's responsibility. Security is shared, not handed off completely. Incorrect, because security in the AWS cloud is a shared responsibility. AWS does not assume all security duties. Option C, the ability to have full control over the physical infrastructure. When moving to AWS, you are deliberately abstracted away from the physical infrastructure. You no longer manage servers, racks, or power. This is part of the AWS value, letting AWS manage that for you. So you actually lose that control, but gain agility and focus. Incorrect, because you give up control of physical infrastructure in exchange for managed services and scalability. Option E, no longer worrying about users' access controls. Access control is a fundamental part of cloud security, and under the shared responsibility model, it remains entirely your responsibility. You must manage IAM users, roles, and permissions. AWS provides the tools, but you must implement them. Incorrect, because AWS provides IAM tools, but customers are responsible for managing access control policies. Option B, the ability to use the pay-as-you-go model. This is one of AWS's most cited advantages. You only pay for the compute, storage, and services you use, with no upfront capital investment. This model reduces cost overhead and encourages efficient resource use. Correct, because pay-as-you-go allows flexible spending based on actual usage, reducing capital expenses. Option D, no longer having to guess what capacity will be required. Capacity planning is greatly simplified in the AWS cloud. You can scale up or down based on real-time demand. Elasticity and auto-scaling eliminate the need for over-provisioning or guesswork around peak load management. Correct, because elasticity in AWS removes the need to estimate and pre-purchase capacity in advance. Which of the following is a recommended design principle of the AWS well-architected framework? Let us identify and interpret key phrases in the question that will help with answering it. The question focuses on identifying a recommended design principle of the AWS well-architected framework. The AWS well-architected framework is centered around 6 pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Key design principles across these pillars include automate wherever possible, make small, reversible changes, embrace failure as a learning opportunity, use evolutionary architectures, and ensure scalability and decoupling. Option A. Reduce downtime by making infrastructure changes infrequently and in large increments. This contradicts a core AWS design principle. AWS encourages making frequent, small, and reversible changes to reduce the blast radius and improve agility. Large, infrequent changes are harder to test, roll back, and control. Incorrect, because making large, infrequent changes increases risk and is not aligned with AWS best practices. Option B. Invest the time to configure infrastructure manually. Manual configuration is discouraged in the AWS ecosystem. Instead, you should use infrastructure as code, IAC, tools like AWS CloudFormation or Terraform to ensure consistency, version control, and repeatability. Manual setups are error-prone and do not scale well. Incorrect, because manual configuration is inefficient and violates principles of automation and repeatability. Option D. Use monolithic application design for centralization. Monolithic architectures contradict modern cloud-native design principles. The well-architected framework recommends decoupled services and microservices to increase agility, scalability, and fault isolation. Monoliths create tight dependencies and single points of failure. Incorrect, because monoliths reduce agility and resilience, opposing cloud-native architectural best practices. Option C. Learn to improve from operational failures. This aligns directly with the operational excellence pillar of the well-architected framework. AWS encourages building mechanisms to identify, analyze, and learn from failures, including post-incident reviews and continuous improvement. The goal is not to eliminate failure, but to use it to drive maturity and resilience. Correct, because operational failure is a feedback opportunity and learning from it is a core AWS design principle. A company plans to use an Amazon Snowball Edge device to transfer files to the AWS cloud. Which activities related to a Snowball Edge device are available to the company at no cost? Let us identify and interpret key phrases in the question that will help with answering it. The question revolves around which Snowball Edge activities are available at no cost. There are a few important contextual cues here. Snowball Edge is a data migration device designed for large-scale physical data transfer to AWS. While device usage typically incurs a fee, AWS offers a 10-day free usage window per job. Data transfer into Amazon S3, i.e. into AWS, is generally free. However, data out of S3 and overdue usage charges are billed separately. Let's evaluate each option. Option A. Use of the Snowball Edge appliance for a 10-day period. Depending on the Snowball Edge device selection and job configuration, the first 15 days of on-site usage are included in the service fee. If you keep the device longer than the free on-site usage period, then you incur a fee for each additional day you keep the device. Incorrect, because there is a one-time setup fee per job ordered, either through the Snowball console. Option B. The transfer of data out of Amazon S3 and to the Snowball Edge appliance. This option refers to data being moved out of S3, likely as part of a retrieval operation to Snowball Edge. AWS charges for data egress from S3, especially if you're pulling data for on-prem use. This activity is not free. Incorrect, because transferring data out of Amazon S3 to Snowball Edge incurs data egress charges. Option D. Daily use of the Snowball Edge appliance after 10 days. Depending on the Snowball Edge device selection and job configuration, the first 15 days of on-site usage are included in the service fee. If you keep the device longer than the free on-site usage period, then you incur a fee for each additional day you keep the device. The per-day fee is listed by AWS region. Incorrect, because daily usage after the first 15-day period leads to additional charges per Snowball Edge device. Option C. The transfer of data from the Snowball Edge appliance into Amazon S3. This represents data ingress into AWS, which AWS generally does not charge for. That means moving data into S3 from Snowball is a free operation, regardless of the volume. Correct, because data uploads from Snowball Edge into S3 are free as they fall under AWS's free data ingestion model. Please note that there is a specific exception related to small files. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.